Great. I
All
think it's
right.
recording now.
All right. Okay. So, welcome to the IndyUseR October 2020 meeting. Um, Today, we're going to be talking about the pins package. And so, if you've never heard of the pins package, you're in good company. I had never heard of it until uh, I went to RCO conference this year, and I saw Javier Larachi, the author of the package, talking about it in a lightning talk. So if you go on to, I think there's a link. Actually, I should mention that all these slides are up on GitHub, and the link for that is just github.com/DSKARD /IndyUseR 202010.
Yeah, and we'll also post the link later in the indie user GitHub page also.
Right. And so, um, uh, real quick, all of these notes are in a file called notes.rmd as well. So you can knit that um, and you'll get all the links and stuff. But uh, there's a quick lightning talk by Javier talking about pins and just introducing the topic of pins. So just real quick, there are, from what I could tell with pins, the purpose of pins is it's all about being able to uh, kind of tag data, or put it in a location where it can be kind of cached locally, or maybe on the web. You can kind of cache it out on the web, and then being able to pull a version of that data uh, into your uh, into your pipeline or into your analysis later on. And so there's uh, kind of two major ideas that we'll be talking about today. One is uh, one is first, how do you create a pin, and then or how do you cache some amount of data, and then the second part is how do you share that with others. So on the pins README page, I feel like they do a really great job of explaining the different things that you'd like to be able to do with pins. They list three different things you can do with them: pin, discover, and share. Um, we'll be talking about basically the first and the third one. I didn't really get around to discovering pins, mainly because my use case was if I have data, how can I maybe save a cached version of it somewhere and either give access to other people or reuse that data myself. So just as a brief introduction, the pins, the interface for working with pins is pretty intuitive. Two major functions that we'll be using. One is the pin function. So with the pin function, you can hand it, um, uh, I guess, if the pin function, it kind of has two purposes. One is to uh, cre- create data in a cache, is to retrieve. Uh, well, I guess it's not. I guess it's really just to create. I mean, it'll go out and retrieve data from an external location and put it into your local cache. So it's really about the caching side of things. So in this example, they show that there's a data set out at this URL, and it's a CSV file, and they call pin with that URL, and that will go out and retrieve the data, and then they feed that into the read.csv function, so that uh, they can read that data in. And if the data exists, so let's go through the two cases. If the data does not exist on your system, then the pin function will go out, grab the data, and bring it and put it into a local cache on your system, right? Uh, if it does exist on your system, then pins is going to go and check to see if the data has been invalidated, or make sure that it's still a valid version of the data, and then just give you back the cache version.
And usually when it tries to check whether it's still the valid version of the data, would it be based on some kind of like a when it was last changed or something like that?
Yeah, I'm not sure how they're doing that cache invalidation.
Hmm. Okay.
Yeah, I think that's
But I can ask around and see if I can figure that out though.
I think that's part of what we touched on at the beginning of the call
Hmm.
with I mean there is a modified date, and then I'm looking at the source right now, and it
Hmm.
looks like I mean, and as you mentioned, Derek, it seems like uh, this changes on a case by case basis, but they do work with something that they're calling e tags, and in fact there is a custom e tag variable in one of their a custom e tag argument for one of their internal functions.
Hmm.
And the dates they treat differently. It's not the usual last modified date. It's I remember looking this up, and it was something else. But they kind of look for remote data. It looks like they're trying to do something with HTML headers, like that you would get from a curl head request or something.
Okay.
That's what it looks like. But yeah, I think asking around is probably best.
Yeah, a head request would allow you to check to see if the data was at that location, get some information about it without having to pull down all of the data. Okay, so to kind of uh, get our conversation started with how somebody might use the pins package, I'm going to lean on my one of my favorite examples, the spirograph example. And if you are new to our group, then I'll give you a quick introduction to spirographs. First thing to note is that it is the easiest way. I know they only say easy, but I really think that it's the easiest way for young adults to make amazing designs, right? And so the idea behind a spirograph is that you can take a pen and some of these gears, and you kind of move the pen, you put the pen into the gear, you put the gear into kind of this blue thing here, and then you move the pen around in a circle, and it creates these little designs depending on which hole in the gear you put it into, right? And the reason why I like this example so much is because we can take a somebody wrote a paper about this a while ago, and they basically modeled a three-wheel spirograph um, as a sum of exponentials, right? And so we can write a little R function that kind of looks like this. We could take an R function, or we can model our a spirograph as a sum of exponentials that looks like this. And uh, we'll have three inputs, one for each of, kind of as a descriptor of each wheel in our system, right? And so here we have our spirograph function. And one of our goals is to be able to uh, create a spirograph and then pin the result, or maybe put our result into a cache. And if we build up enough of these results in a cache, then maybe we don't have to go through and calculate all the points that are going to be involved in plotting out a spirograph. Every time we want to plot it out, we can just go back to our cache and say, let me grab the output from the cache. So just a little bit about how our regular spirograph function works. We have our spirograph function here, and it's going to take about 1,000 points, run it through our sum of exponentials, and give us back xy points that we can plot later on. Right? So if we give it 3 inputs, n1, n2, and n3, hand that over to our spirograph function, then we should get back, in this case, a tibble with X and Y columns. And when we plot that, it'll look like something like this. So this is I think this is the 7, 13, 7 spirograph, right? And so now I'd like to be able to save this data, but I have to be a little organized in how I save my data. There's a couple of things I might be interested in. First, I want to be able to tell maybe when was this spirograph first created. I want to be able to store the inputs that I used, and then also I'd like to store the outputs that I use. So the outputs, because they are X and Y data points, what I'm going to do is I'm going to store those as list columns in a tibble, right? And then the date, I'm just going to store the date and then all the inputs. So now I have one row in a table that specifies what were the inputs for my simulation and what were the outputs. And I can do, okay, so now we can save this result to the local cache by calling the pin function. So the first thing I'm going to hand the pin function is the data that I just created. So this data frame or this tibble that I just created, and then I'm going to give it the name spirograph results. So this is going to be in what's called my local board or my local cache. And anytime I want to retrieve the result, this particular result, I'm going to use the name spirograph results. So we can use the pin get function to retrieve data from the cache. So in this case, I'm retrieving back the results that I just put into the cache. Okay. So you could imagine that if we wanted to build up a cache, we could just do this over and over again, where we calculate different spirograph XY points using inputs. We put them into this format, and we can build up a table that includes inputs and outputs. So here's a second spirograph that we could calculate, the 13 minus 7 minus 3 spirograph. We'll get the results. We'll do the same thing where we plot it. It'll produce a spirograph like this. And then we can put it into our same format. Second, we're going to call it second spirograph data. It's just going to be a tibble with the date, the inputs, and the outputs. And if we combine these two together, so we take the data from our first spirograph, the pinned spirograph data, and then combine the second row or the second spirograph data with it by binding all of our rows together, we're starting to build up this cache. And we can pin this new variable, all spirographs data, where we have two different spirographs that we've cached. Now there's another function called pin versions, and that allows you to see the different versions of data that you've cached so far. And I think we mentioned this earlier. In your local cache, Okay, there's different types of caches you can have. We've only talked about the local cache so far. In your local cache, there's no versioning by default, right? So when you ask for the versions that are for this kind of pin or this pin on your local board, it's going to tell you that there are no versions right now. But you can turn on versioning for your local board or your local cache by using the board register function. So you can say on the board called local or my local board, turn on versioning, and then we'll go back and we'll pin the first spirograph data as our first version, and then we'll pin we'll use the second version will be all of the spirographs. So the first and the second spirograph that we created, we'll pin that. And now when we ask for versions, it'll tell us that we have 2 versions. And these versions are when it's dealing with a local your local cache, these versions are, I guess, all this versioning information, the cache is stored on your local computer. So if you have to, if you don't have internet or you want to get back to a previous version that you hadn't shared with other people, you can go and uh, ask for the pin named spirograph result from the local cache, and you can specify a version of that pin that you wanted to use, and it will go and get it from disk.
So kind of previously, before you had that board register command, when you said, I think if you go up a little bit, when you, yeah, like, yeah, a little bit down. So for example, when you did the second, yeah, that pin all spirograph data. So at this point, it would have just overwritten the previous one. Is it?
Yeah, it overwrote the first one.
Okay. Okay. And then once you had that board register, that's when after that, whatever you do, it kind of starts versioning. Okay.
Right. So yeah, when we registered the local board with versions turned on to true, then I think this one overwrote the first one, and then like whatever we had in there previously,
Okay.
and that became the first version.
Okay.
And then this one became the second version of the data.
Okay. Thanks. And quick question: is this? I'm trying to see the we compare it with, like, typically in R, like at least previously, if you wanted to just store a data frame or something, was it like a save command or something that saves it as a, like a .rds format or something like that?
Yeah. So I
Is
don't know
it,
if the command is save RDS or just save.
yeah, something along those lines, and then you could say load or something, and then it'll load it back. Uh,
Mm-hmm.
I'm wondering if this is kind of a more robust version, kind of.
I think it is. Under the hood, I'll have to look to see. Let me see if I can figure out. Uh, Let me just do a search real quick. Under the hood, like when you say save these, like pin these things, it is like at least for the case where you have a data frame or a tibble, I think it does save it as a .rds file. And so there are RDS files on disk. Let me
That's kind of what I'm seeing in the code too for data frames. Exactly. Um, I haven't checked the output though, but it seems like I don't know what their policy is on big data though, because I feel like it'd be easy to choose a format that's faster and more condensed for serialization, like one of the FST or Arrow or Parquet formats to save data frames. I mean, I can understand they don't necessarily want to incur another package dependency, but I mean, for big data stuff, I've become a believer in those formats.
Mm. Yeah, I'm not sure. I'm not quite sure how they're dealing with larger formats. Um, I imagine that. I mean, you mentioned the arrow format, and I do remember seeing an example where they're talking about being able to read the arrow data format like really fast, like over multiple files. You know.
Really, pins?
No, no, not pins. Just the arrow package in general.
Uh,
So I was thinking that that would be like if you were saying, okay, we need to serialize this large data set to something. It's like, yeah, that would it feels like that would be a good place to or a good data format to consider serializing it to.
I agree. Um, yeah, I've seen benchmarks, and I usually prefer FST because the I mean because the trade-offs between read and write speeds are aligned a bit pretty well for pipeline tools, at
Mm.
least in the benchmarks that I've seen. But I mean, our studio makes Arrow, our studio makes pins. It seems like they should get together.
I think Arrow is made by it's another group, Ursa Labs,
Right, Wes
right?
McKinney
Yeah, yeah,
in
yeah.
that group. Oh yeah, yeah, you're right. It's not an R Studio package.
Yeah.
No, but I think there was
Oh,
collaboration between like West
yeah, there's
McKinney and
collaboration.
Mhm.
Okay, um, so the next topic I was gonna kind of touch on was how do you go about sharing this data with other people, right? We've talked about like your local cache and your this thing called a board, your local board. But it turns out that if you want to share data with other people, you have to. I mean, you could put it on a zip drive. Uh, Anybody out there still using zip drives? No. Okay. Uh, you could put it on a USB stick, something. But we have the cloud now, right? So there's all these cloud services that you can use to kind of host your data, and some of them even have structures where you can give other people permission to view or manipulate the data. And so I was playing around with this, and I'm not super knowledgeable in AWS. So I think for my first example, I went and did this in GitHub. I said, I like I like the fact that I can just throw stuff up on GitHub and other people can access it. And so I went and kind of explored how do you get a cache on GitHub. So um, Pins has this concept of boards. Boards, I think of boards as just another cache, another place where you can hold data, right? So GitHub is one of those other places where you can hold data. I think they have helper functions to allow users to kind of access data that is on uh, what is it, Kaggle, um, GitHub, Google Cloud Platform, Azure, AWS S3. A lot of the major um, places where you might say, oh, somebody has stored a data set here, or I would like to store my data at that data set. And I think there's also helper functions if you have your own store for your own way of storing data on an external site. Then I think that you can write your own kind of plugin uh, that'll allow you to access that data with the pins package. So the example that I kind of came up with was what would it take to get some data put up onto GitHub so that other people could access it. And so the first thing that you'll have to do is put together what's called a GitHub personal access token. And so I kind of wrote out the instructions, what you have to do. You got to go on the GitHub website. You're basically getting a token uh, or like a string, a special string that will allow you to authenticate yourself to the GitHub API and prove that you're allowed to either read or write data to a repository. So if you're setting this up for the first time, you can go on to GitHub. If you go into the developer settings page, there's a place where you can create personal access tokens, and you'll ask for a new token. The process for getting a new token is pretty simple. You just need to give your token a label, and then click on the public repo checkbox on the web page and click the submit button, and it will hand you back, like, I don't know, it's probably like 16 to 32 character string that you'll then put into your R environ file. So your R environ file is it's a place where you can put environment variables that'll get picked up by our processes that are running. And you'll create this, so inside of your .r environ file, you'll create an entry called GitHub PAT. And so uh, you could edit the environ GitHub file, the R environ file yourself, or you can use this package as a nice nifty function that'll allow you to open up that file and um, set up the environment variable. It's going to be the name of the environment variable, which is our GitHub underscore PAT, followed by an equal sign, followed by the string that you got back from the GitHub web page. And after you do that, restart your R session and check to make sure that the environment variable is getting picked up, right? So that's the first part, is making sure that you can authenticate yourself to the GitHub service um, with the personal access token. The second step is to create a new repository where you'd like to store your data. So I created a repository called IndyUseR 2020-10-data. So that's going to be the name of my board. It's also the name of my repository. I just made it a public repository and I didn't put anything else in it. So, all right, so the next step is to register your new board, right? So I'm going to use the board register GitHub function, which is a helper function to help you register GitHub boards, GitHub-based boards. So the name of my board is IndyUseR 2020-10-data, and it's associated with the GitHub repository that I just created. So under the hood, the pins package is going to, when you ask for something to be cached, it's going to store the data at that location. And then when you ask, any other people can ask to retrieve the data from that location. All right, so next, we can pin our spirograph data to the board by using the pin function, right? So similar to earlier where we said pin and then the name of the variable that's holding our data, and then we give that pin a name. So this pin is going to be called spirograph results, and then a description. And then, but I guess most importantly, you got to tell it what board you want the data to be pinned to. And so I'm telling it, send that data up to the board that I just created that's associated with this GitHub repository. Previously, we were sending this data to the local board, and now we're sending it up to the GitHub board. So I've been running this. I've been playing around with this board for a couple of days now, and so when I ask for what versions are available for the spirograph data from the GitHub board, it comes back. I guess there's quite a few versions that are now available. Looks like there's 19 different versions of spirograph data uh, in this repository. And if I go up to, let me just real quickly go up to the repository in GitHub. Just gonna stick a data at the end of this. You can see that, yeah, there have been 20 commits, and all that's stored inside of here is the name of my pin, which is spirograph results. And here's the RDS file that we were talking about earlier, the data.rds. And that holds the kind of the serialized um, uh, Tibble or data frame information that we were seeing earlier. There's also a file called data.txt, and this is a little YAML file that describes what data is stored inside of this pin. So there's 2 rows, 6 columns, and you can see all the columns that are kind of listed in there. And it looks like it's also available as a CSV file. So. And then this other YAML file that's at the top kind of lists out what pins are available. So uh, earlier we mentioned that there is a third pillar of things that you can do with the pins package, which is discovering pins. And I think that this data.txt file is how the discoveries are made. So every time we add a new pin to this board, a new entry will be added to this data.txt file. So any questions so far?
Yeah, so it looks like the spirograph results folder, I think I'm only seeing a single, what looks to be a single result, unless data.rds and data.csv are for 2 different objects.
I think that because, so right now we're looking at the most recent version of this. And so I think what's happening is that there are like multiple commits to the repository.
they're
So
in different
each of those
commits.
is going to have a different version of the data. So if we were to look and say, okay, what's the most recent hash? Is this 1EB 2542? Well, let's just remember 1EB, because that feels like that's pretty unique. And then we come out here. So we say that it was created, this 1EB 2542, it was created 22, 23, 33.
Of course, that's how they did it. Thank you.
Right.
Yeah, that makes so much sense.
So it's really relying on for the GitHub board, it's relying on the already created versioning, or the already available versioning from GitHub, from the repository. But with S3, I was Javier messaged me back and said that they were using e tags when available. Let me just I'll paste the response into the chat so so we can read it.
What is an e tag actually? I'm not familiar with that.
Will, do you want to expand
I
upon e
can
tags?
I can
Not really familiar
try.
with
It's
them.
I can try. It's a web thing. It's an HTTP thing. It's short for entity tag, and um, it's it's like a hash that's optional
Mm,
that that a lot of websites just generally choose to provide for their online data files and websites. So um, it's not perfectly ubiquitous. It's something you can't totally rely on. And the format of the e-tag, I mean, it's supposed to be a hash, but the format of the e-tag is really up to the server,
mm,
or the whoever is maintaining it. Um, so, but if it is available, then the way you would get it is through a head request to that endpoint, um, and you'll be able to find it in the in the headers if you do, let's say, uh, if you do a head request, and you can do that in R with a head function from HTTR, or you can do that directly in the curl package with as long as your hand, um, and if you, I mean, curl style get requests, they style requests, I mean, by default they get everything, but just to get the headers, you can give it a special handle with nobody equal to true. Nobody is an argument, um, and it'll just pull the headers instead of the actual, instead of all the content. Um, I mean, e-tags and last modified timestamps are usually, I mean, the things that I've found for the websites that I've looked for. But I mean, I am not an expert in this. I've just tried to to sort of work with remote data tracking for Drake and targets. Um, Amazon S3 supports its e tags. It's for buckets. An object in a bucket has an e tag, but it is not, and it is guaranteed that the object in the e tag, the ones that are available are sort of, they match each other. Um, but it is not guaranteed that if you overwrite an object that and you sort of asynchronously or just in quick succession try to get that object or get that e tag back, that you'll always be getting the perfectly most recent one. So there is some latency um, in that whole process. I don't know. That's just my experience. I'm not I'm not the most knowledgeable about this, but I can certainly I mean, share it's kind of what I've experienced them to be and use them for.
this is helpful. Thanks.
Yeah. All right. So I know we're coming up on an hour for the meeting. I so if anybody has to has to leave, that's fine. But I have one more, probably one more. I think. Let's see. Oh, I guess the two more things to say. One of them is short, and one of them is probably a little bit longer. But the last the last part of this example was to retrieve the data after we or use the retrieved data to replot our spirograph, right? So basically, what we're doing is we are we're grabbing the spirograph data that we got from the pin, uh, filter out the the spirograph, the inputs, filter by the inputs. So we want n1 equal to 13, n2 equal to -7, n3 equal to -3, and then uh, kind of explode those list columns that we shoved into the tibble in the first place, and then plot the xy points. And so that's kind of what we're doing here. We're using the unnest function to explode those list columns out of the result that we stored earlier. And then kind of the last thing that I wanted to go over really quick was that we could use this same idea inside of a Shiny application. So I know earlier somebody had mentioned that they were banging their head against the wall for some Shiny stuff, and that's kind of where I was earlier today with trying to add this pin-based caching to a Shiny version of the Spirograph application. And so I think I just wanted to go over a couple of the highlights from that code. The code is in the repository under, I think there's a directory called called Spyro Shiny Solution. Um, but just real quick, let me just open up the code for that. So what we're doing, maybe let me show the code for the regular spirograph first, because it's not quite as involved. Um, what we're doing is we have our normal spirograph function here, and uh, this is the same function we talked about earlier. Um, we create this sidebar layout for our Shiny application. So on the side panel, we're going to have our 3 slider inputs, and in the main panel, we'll have the XY plot. And then for our server, once we get inputs from the user, we run them through our Spyro function to calculate the XY points, and then we plot the output. So that's basically the Shiny version of Spirograph. And in order to get this to kind of read from the cache, couple of things I learned today. So one of my goals was to put a little or one of my goals was to be able to read the information from the cache and store it locally. And so I did that by first, uh, I guess I have a couple of variables that describe all the hard-coded stuff, like what version of the results I want. So this is the hash that came out of GitHub. This is the GitHub repository that's holding my board. This is the name of my board, and this is the name of the pin on the board. Right. So I first go through and register my board in the application to let the application know that there's a board called IndyUseR 2010 data, and it's associated with this GitHub repository. And then the next thing I do in my Shiny application is I retrieve the cached data, and I store that in a variable called pinned spirograph data. And this is our regular spirograph function up here, so nothing has changed in that. But I added, actually, I don't even think this is relevant anymore. I started to add another function, but to be able to save data back to my cache, but I don't think that's needed for this, so I'm going to skip that for now. All right, so the user interface to the application is almost identical. We have our 3 slider inputs in the sidebar. We have our XY plot in the main panel, but I also added this text output called cached. And this is just to let us know, are we using a cached version of the output, or did we actually calculate the spirograph from scratch? And then inside the server, um, let me just jump down to when we do the plot. The first thing we do is we take our pinned data. So this is our cached data right here, and we filter it based off of the inputs that the user has chosen, and we check to see, did we get a result? And if we didn't get a result, meaning that the number of rows inside of this result is 0, when we filtered, there were no uh, there were no we didn't have a row in our tibble that had these 3 inputs. Then we go through and just run the calculation for spirograph from scratch. and we set our cached value equal to no, right? But if we did find a result, then we go through, we select the X and Y columns from the tibble, and then we explode them. So remember before they were list columns, and we're just exploding them so that we get back a tibble with 1,000 rows with X and Y data pairs inside of them. And then either way, we're going to plot the result here, right? So let's just run this real quick. So you can see what's going on. So in our application, we have the sidebar layout. You have three sliders and your XY XY plot here, and we have another output for cache result. So this 13 minus 7 minus 3 result, this has been cached. This was one of the two results that we had inside of our cache. And as we change the value, it's recalculating, but you can see that the cache, we're not using the cache anymore. It's calculating these by hand or from scratch. So if we go back to the other value that we had stored, I think it was 7, was it 7.3? 7, maybe it was 13. 7.13.7. It went back and it found the cache result for that. So, all right. So just to kind of sum things up, the pins package, you can use it to cache data locally, or you can share that data with other people by posting the cache data to like a board that is not your local board. So other external boards that you can post that data to, things like GitHub. We showed an example of how to kind of set up a repository that can host different pins up on GitHub. Remember, if you set it up on GitHub, you have to also set up some kind of personal access token as well. You can post things to S3 buckets, Google Cloud Platform, Azure. I think Kaggle was another website that they said that you can use pins with. And so that's kind of like my brief overview of using Kaggle, putting it into an application, and then if the calculation for spirographs was more more intensive, then we might be able to see some real benefits. But in this case, because spirographs are fairly fast to calculate, you don't notice too much of a benefit, but we can at least see that we're using a cached version versus not using a cached version. And I could also imagine putting another button here that says save this to the cache and having that post up to GitHub, so that if you were to find a new spirograph that you wanted to share with people, then you could save that spirograph and put it into your cache for other people to see. Any questions?
This was nice. Thanks.
No problem.
Yes, thank you.
And I always like the spirograph example.
Yeah, it's a really it's my go-to for whenever I need a quick calculation, because nowadays I don't tend to do too much in simulation right now, and so sometimes coming up with examples it's like, okay, now I got to think of an example, and the example has to work and all this stuff. But spirographs are they're fun to talk about, and fun to see the different shapes that you can produce as well.
Yeah, I like that. And I hear I share the struggle and empathize with. Do you want to teach the thing, or do you want to come up with the great example? It's kind of like you have to choose one,
Yeah.
right?
Yeah.
But thanks. This is great. I feel like I have more of an intuitive feel of what Pins does now.
Yeah.
And I'm assuming here, even though in this example we were using a table or a data frame, it could be any R object, like a list of different objects and stuff like that. As long as it's just saved to a variable, we'll say pin that variable.
Yeah, and they had on the web page. I've seen examples of. I guess the two examples I've seen so far are like data frames and then CSV files. You can like read in CSV files, but I think the pin can be any kind of resource that you can download as long as you know what to do with it once you get it.
Hmm.
you know so with the CSV file, it's like nothing like nothing by default is going to happen with the CSV file, but you know that you can read it into another. You can use the read CSV function to read that and munge it into something else. So I
Okay.
think it's like there's some analogies to if you were to just use curl to grab something off of the internet, instead of using curl to just grab it off the internet, maybe you say, let me use pins and I can put it into my local cache.
Hmm.
And if it's out on the internet and it gets changed, then I can get the new version. But if it, goes away, then I still have it in my local cache. Or if I don't have internet connection, I still have it in my local cache.
Oh.
So I have some side projects that I was working on where one thing I do every week is I run a little program to go out and scrape the web for different information, and then I store that in. I think I store it in like some CSV files, and then I read that into an R program to and turn it into like my own little analysis. And I was as I was playing around with pins, I was like, oh, I wonder if instead of going out and grabbing all this information and like some of the information is just repeated, I wonder if there's a way that um, I can just use I can use pins to kind of cache that information and build up a history of what the information used to look like over time. You know, so that's probably where I will be going next with my pins exploration.
Just curious, for web scraping, do you use R or Python or something else?
I'm using Python right now because I started off with using R because it was part of my effort to learn more about R and become a better R programmer. So this particular project, I said I'm going to do everything with R and I'm going to figure out how to get it done. And so I started off scraping the web with R and just asking these web pages for their information and stuff, and using what was the name of that? I think maybe it was like HTTR package and maybe some other ones. And then the website that I was kind of pulling information from, I wasn't scraping their website. I was just using their API, and then they made it harder to use the API because I don't think that they have I don't think you can get an API key or anything. I just went on the website in my browser, looked at the network traffic, and then imitated that network traffic with my HTTR calls, and then they started they started returning they started like blocking my requests and stuff. And so I think I played around with a couple of other ways of doing it, and then I was like, this is not what I like. Grabbing the information, like trying to get around their whatever they're not happy about, is not what I'm interested in. And so I put together a little Selenium and Python script, which is uh, kind of like my bread and butter for web web automation, like my lowest common denominator. Let's just open it up in a browser and scrape it that way. And
Cool,
so that's how I'm doing it now.
cool. Thanks.
Yeah.
And that tip actually is the R Selenium solution. That kind of there were previous talks before you joined about clever ways to get out of the API limit situation through websites by inserting artificial delays. And
Mm-hmm.
gosh, that sounds like a much better idea
Well,
than I mean, the R Selenium thing that you proposed. I mean, the Python Selenium thing you
yeah.
proposed, and there's the R Selenium package. So,
Mm-hmm.
I don't know. It's a whole other thing we could revisit.
I prefer using the API because when you're scraping HTML, I feel like it's less defined. Like the I don't want to get into a position where I'm always trying to adjust for user interface changes on a web page. I just want to say I want this data, and if I give you the right, the right uh, payload for my request and give you the right kind of request, make the request to the right endpoint, then you'll give me back data that was meant to be parsed by machines, like in some kind of JSON format or an XML format or something like that. When you get into scraping web pages, it's like you're just waiting for the next time they do a user interface change, and then your whole thing breaks. And it's always like it's never at a convenient time because they never tell you when it's going to happen. It's when you're busy. And then it's always like 3 months, 3 years down the line where you're like, this thing has been working for like a decade. Why did it stop failing now? And then you got to go dig into like 3-year-old code and wonder what you were doing. Like, what was I thinking?
Right. I think I suspect that's part of the reason why CRAN looks the way it does. Their website that it's just a suspicion. I mean, it looks. I mean, if you open it up in a browser, it looks pretty quaint. But if I mean, just looking at the raw HTML, it's like, wow, it's bare bones. This is the shortest HTML file I've ever seen when I inspect the source. It's great. Yeah, and I feel like some of the most frustrating parts of my job, and one of the reasons that 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 my company internally, it feels like it's like the workflow stuff is having such a hard time technologically, is that people build tools that they don't think are going to be automated. But you want to, every time you want to build something, you gotta interact with automated components. And I mean, I see this at every level in my daily work, from clinical trial simulation tools to how our data gets stored and processed. It's just all these things that oppose automation and that limit our capabilities, just because people don't think that we're going to need to do this. I mean, stuff that's conceived, not by software engineers, and the whole contracting out model to people who don't really understand why they're doing this or have an incentive to plan for 5 years down the road because they're just going to move on to another contract. It's real tricky. And I guess some of my biggest but weirdest wins have been just developing as contracting back out to say, hey guys, remember this? Could you write this thing that makes this work on Linux? So anyway, I'm done ranting, but yeah, I know what you're saying.
No, it's definitely, it's a battle. And so when I try to either not start things that I'm like, you know what, in the future I may not want to manage that, so that's why and a lot of times I'm when it comes to managing systems and stuff, I'm like, maybe I shouldn't do that, because I may have the energy to manage this now, but I don't think I'm going to have the energy or the excitement to keep managing it, in a year. Like, I want to be doing something else in a year, So that's how I feel about databases.
Yeah.
I love them when they're when I don't have to manage them. I'm like, oh great, resource.